Hello, welcome back to Coding Everywhere. Today we will continue writing our simulation program in Python. In the last video we added the gravity and we wrote the algorithm to the second Newton law. Today we will write code to implement the third principle. According to Newton, in the third principle, the action force of an object into a second object is equal with the reaction of that second object in the first one and in the opposite direction. So that means if we have the ball on the floor, the reaction of the floor will be equal with the negatives of the gravity, and there will be no force impressing on the ball because the summation is zero, so the ball will not move. If the first object is moving, like our ball, and the second object is anchored such that it cannot move, like our floor, the bouncing object will move away from the anchored object with a velocity almost equal to the impact velocity. So let's just figure out what is that almost equal. If the impact velocity is too small, there will be no bouncing. That velocity will be converted either in heat or used to do scratches on the ball or on the floor. We will call that minimum velocity required to escape from the floor escape velocity. If the velocity of the ball is larger than the escape velocity, it will escape. Otherwise, it will stay at rest and not bounce. That escape velocity is a function of the material of the ball and of the material of the floor. So I will start by defining an escape velocity of 10. So escape velocity is equal to 10. If our ball has a velocity smaller than 10, it won't bounce. And then let's just apply the third principle. So to have the third principle active, we need to have contact. So we'll say if y of the ball is smaller or equal than y of the floor, which is negative L, plus the radius of the ball. So in that case, we have to say y is equal negative L plus R, which means that the floor cannot go through the ball cannot go through the floor. Then we will say that the new Vy is equal with negative Vy minus escape velocity. And now we have to check if our new Vy, if it is negative, so which means that the initial velocity was smaller than the escape velocity. So if Vy is smaller than 0, we'll have Vy is equal 0. Okay, now we know that after 10 seconds we do not hit the floor, so I will run the simulation for 600 DTs, which is 60 seconds. And just to have things being presented faster, I will modify this sleep period to delta t divided by 2. So we'll simulate 60 seconds, but the program will run just 30 seconds. So let's just run it. Okay, so we are drawing the walls. Then we are bringing the ball at the top. The ball is falling. Right now the second principle is applied over and over and over. We hit the floor and we bounce. We won't go right to the top because we lost the escape velocity, and then let's see if we might have a second bounce, and then at some point it should stop. This ends our implementation of the third Newton principle for the floor impact. Thank you very much for watching. Please subscribe to Coding Everywhere channel to be updated whenever new videos are uploaded. Bye bye.